Hello, everyone. My name is Bryce Babinick, and I am a 3D printing technician here at MLC CAD Systems. And today I'm going to talk about maximizing efficiency with Eiger. For anyone who's not familiar, Eiger is the slicing software for Markforged 3D printers. And if you're new to slicing software in general, that's all right too. We're going to go through a quick explanation before diving in. But the reason we're talking about efficiency with Eiger today is because it's actually a lot more than just a slicing software. Eiger is specialized really for business or industrial environments, so it has a ton of extra capabilities that you won't see in other slicers, especially at the hobbyist level. And so our goal today is really to show how a business can take advantage of all these extra capabilities and they can use it to improve their overall efficiency. So whether that's cost savings, time savings, higher security, or maybe just being more organized, Eiger has a feature that can help you. Whether it's any of those things, we should be able to get you covered. And here's our agenda. There's a decent amount to cover here, so I'll be mostly doing an overview for each one of these things, just to really show how to take advantage of each one of them. And if there's a specific feature that sticks out to you while we're going through this, the odds are that we have a deep dive for it already on our YouTube channel somewhere. So let us know, and we're happy to send you a link, or even go through a demo with your own models if you want to see it in action. But for today, I thought it would be a bit more interesting for myself and for you guys if we went through an example scenario. And that way, we're not just droning on about the features and what they are. We're actually showing how they can be used to make life easier and speed things up. And during that process, we're going to more or less follow the order that we have here. And so we'll start simple with a very quick definition of slicing. Then we'll introduce our scenario, and then we'll get started slicing with Eiger. But again, it's not just a slicing software. Eiger was built to be used by a whole organization and not just an individual person. So it has a built-in file management system with print statistics and even an ROI calculator. So you get a ton of handy tools, and you can use those to manage your users and devices even. And so those tools are great for your everyday time savers, but I think simulation is where things get really interesting because Eiger has one of the only 3D printing simulation softwares in existence right now. And I know it's already saved us a lot of time and money on parts that we've made for ourselves and for customers. And so that's always one of my favorites to go through. But last but not least, we will also talk about inspection, which uses a fully automated process to create a deviation plot report. So you can have confidence in your parts and their geometries, and you can use that to help with your process control. That one is not as fun for me personally, but it's always a favorite for the quality departments. Without further ado, though, let's go ahead and get into it. All right, I did say I'd quickly answer this question, so here it is in a nutshell. With printing, you really need to start with a file from a CAD software, and we would love for that software to be SolidWorks, of course, but it can come from any CAD software that outputs an STL formatted file, and that file holds all of the dimensions and the features of a part, which is pretty standard for really any manufacturing processes. You're going to need some type of CAD file, but we can't go straight from the CAD file to 3D printing because the CAD file and the printer don't really speak the same language. And so we use a slicing software to translate the CAD file into something that the printer understands. And slicers got their name because they essentially slice a 3D geometry into a series of layers that stack on top of each other to form a part. And they also send a variety of print settings like temperatures and material flow rates and movement speed, just to name a couple of them. Hopefully that makes sense so far. And slicing softwares in general have been around for quite a while, and there's a ton of them out there. But Markforged got their claim to fame by adding a new mechanical process for 3D printing. So they started embedding these continuous fibers that can run around the outside of a part or fully fill it. And it adds a ton of strength, so it's great for that. But it meant that they couldn't use any existing slicing softwares, and they had to create their own software, which is called Eiger. And fast forward, 10 years or however long it's been, and now they're as much of a software company as they are a hardware company. But we'll start with slicing just like they did. And before we hop over to Eiger, I mentioned earlier that we would use a few example scenarios to show these benefits in action. And so before I get into this, I wanted to mention that you may not use every feature of Eiger for every part like I'm about to do, but I did want to cover as many things as possible in one go through just to show where you can add efficiency, and you can kind of pick out which ones may or may not be relevant to you. All right, so I don't know about you guys, but I'm definitely more of a visual learner. So I set this thing up here in SolidWorks just to help me sort of explain this as we go through. And if you've taken an advanced assemblies class with us before, you might have seen this scenario. But we're going to say for this scenario here, I'm an engineer and I work on the manufacturing floor at a facility. And this is just one of our production lines there. And then on this line, we have an operator who runs this machine. And this machine sort of slides back and forth and it performs some type of post-processing step on our products as they're coming down the line. But we'll say maybe today he made a mistake and he ran this thing too hard right into the side of a part. And now, we have to scrap our part. Our cutting bit is destroyed. And then worst of all, these brackets on either side of this motor are warped and bent beyond repair. And so now we need to get this thing back up and running as quickly as possible because, as you guys are familiar with, we have, production quotas we have to meet. And so we can replace the cutting bit. We've got some spares of those, but these brackets aren't something that we keep on hand. And, we could take our CNC machines out of service to run these parts on them, but then, we're behind on products on the CNC machines as well. And, we can't afford that. So that's really where the Markforged comes in and one of the biggest benefits of it. If I had a standard FDM printer, I might be a bit hesitant to print a metal bracket like this. But because Markforged can reinforce their parts with carbon fiber, and then on top of that, because I can simulate those forces and test everything out before I even start the print, I'm pretty confident that I can take this thing over at least to Eiger and run the simulation on it and see how it goes before resorting to the CNC machine. So the first step is really, just building our part out in SolidWorks. And we may have had a model for this already, or it's relatively simple. We could whip up a model pretty quick. But from there, it's time to open up Eiger, and we can start to take our first look at it. All right, so here's Eiger, and there's a lot going on here at first glance, but one of the critical things for us, just to start listing things off, is we've got over 2,000 parts that we've built up in our organization. And so we're able to store all of these parts within folders and subfolders here to keep things organized. And so it's just a really convenient thing that we use all the time. And it's easy to use because it's just like Windows File Manager. And so here at the top, you can see I'm in Bryce's parts folder, and then I'm in the demo parts subfolder. And that's where I'm probably going to stay for most of this webinar, just so I don't accidentally show any customer parts. And we could also control that using some folder access security, but we'll talk a bit more about that later. For now, once we're in a folder, we can see all kinds of useful information. Like we've got a thumbnail of what the part looks like. We can see the name of the part. We can see who worked on it. And we can even see what type of material it was printed with, both plastic and fiber, if fiber was used. And then to take that a step further, we can even filter the list in this folder by one or multiple fields. So there's a lot of really good ways to search through things as you build up what we call a digital inventory. And the reason we call it a digital inventory is because all of a sudden, you don't need those shelves and shelves of extra parts. You can store your digital files here, and then you can just print them when they're needed. So it can save a lot of space that way as well. And then you don't have stuff that's getting outdated where you don't even need it anymore. You can just update the file. But getting back to our scenario, I'm going to go ahead and I'm going to create a folder here. And as you can see, it gets the permissions from the parent folder. So that's just fine. We're going to go ahead and hop into it. And then I'm going to select to import our parts. We've got the two that I need right here. And there's a few things going on. Even when you're importing your parts, you can take the default settings, but you can set up organization-wide configurations. And so that's, if you have a lot of similar parts and you're always using the same settings, you can use this configuration, which is a pretty convenient way to save you some time. I'm going to select the folder I'm going in as well, and then we can just hit import. And that brings in both parts at the same time, and I can flip back and forth between those parts, the left bracket and the right bracket, just using these little squares down here. And I can also change the settings for both of them at the same time using these batch settings over here. But first thing I want to do with these is lay them flat for the proper orientation. And then I want to change the printer to the FX10. That's the latest and greatest, the fastest printer we've got going right now. So I'm going to go ahead and apply these settings. Let that load for a second. And so once you're happy with your settings, you can just batch save, and that'll save those settings for all of the parts you have pulled up, whether it's 1 or 10 parts, it'll run through and save them. And by now you might have noticed that I have multiple Eiger tabs open here. And that's another one of my favorite things about Eiger is it runs in the cloud. And so all this stuff is happening on Markforged servers. And so I can really navigate away and I can let it slice in the background. And it doesn't take that long, but just so we're not bogged down today waiting on things, I went ahead and pre-did a lot of this stuff. And so here's an example of one of those parts after we have sliced it. And it's super straightforward and easy to use because we've got our materials selected, and Markforged has done all of the testing for those materials. So we don't have to play around with temperatures and flow rates or anything crazy like that. All of our settings are pretty much defaulted most of the time, and everything is going to come out just fine over on this side. On the left-hand side, you can start to get an idea of how much it's going to cost to make your part and how long it's going to take to print that part. And then one of the other things that's unique about Eiger is we have this custom fields add-on. And so this is very convenient. We use it typically if we're using some type of hardware with our parts. And so I could enter in here and say we're using, maybe 3 hex bolts for each one of these bolt holes. And then at the end of the month, there is an Excel report that you can spit out, and it lets you know how much material you've used and how much fiber, all that stuff. But it also includes these custom fields. And so at the end of the month, we can have an idea of whether or not we need to order more of these hex nuts or hex bolts that go with this part. One of the places that we also use it a lot is for this business purpose field, just so we can look back at the end of the month and see, all right, we've spent a lot of money on material. Where was this money going, and kind of distribute it that way. And then the last thing over here on this left-hand side is another really convenient piece, which is that you get some version control. So as you are changing any settings and playing around with things, if you find something works better than a different setting, then you can actually revert back to it or kind of go look at it and see what your thoughts were at the time. And so just lots of really convenient tools in here as you're working back and forth within CAD. And as you're doing that as well, you can come in and even update your STL. So if you change your CAD file, you can just come in here. You don't have to re-upload everything and redo your settings. And before I move on, the last feature on this page that I think is worth mentioning is this Submit for Review button. And so this was added to sort of encourage interns or people within the factory floor, whoever it may be, to start using this technology because it is so straightforward, and they've created this easy to use ecosystem. And so this allows people to start getting in here, slicing parts, and they can then submit it for review, where a manager or some type of administrator can then approve it and give them the go ahead, or they can see if maybe there's some obvious mistake or error there. So it is a pretty cool little feature that they've added on recently. Once you've got everything all set in this page, though, you're going to hop over to the X-ray view, and that's where we start to have some fun with this carbon fiber reinforcement. And again, I've already set this up just so we don't have to step through each little piece of it. And so this is what we see in our X-ray view. In blue, we've got our carbon fiber. In white, we can toggle on our part. And then in purple are just going to be our supports. And so on the right-hand side here, you can see I've set up 3 different groups of fiber, which is pretty standard as we're working through parts most of the time. One of these groups is on the bottom layer, and so we've got a fully filled layer of fiber, and it rotates to give strength kind of uniformly in each direction. And then I repeated that fully filled layer on the top. And I did that on the top and the bottom of this part to create a full sandwich panel. And so those sandwich panels are going to fight forces that are coming in perpendicular to this part. And the reason they're on the outsides is because that's where you're going to have your highest tension and compression for this type of force. But in our case with this part, if we look back at our model here, there's not really any force coming in straight at this bracket. It's all going to be as this bit is being pushed into a part on the line here, it's going to be resisting and pushing the bracket sort of off to the right-hand side this way. So in that case, we don't need to fully fill every layer. And so on the inside of those two sandwich panels, we're just running a concentric loops of fiber, which only run against the walls. And so that gives us a lot of strength in that parallel direction without spending, extra money on fiber. And so this is great, and we've got our part set up just how we want, and we could go ahead and print it, but we don't have full confidence yet that this thing is going to work. Again, we're replacing a metal part here, and we want to know, before we spend however long it is printing this part, that it is going to work, because we need to make alternative plans if it's not going to work. And so the best way to do that is to just hop over to our simulation tab, and we can start laying out our forces. And so we've already talked about this a little bit. We know that this thing is mounted using these bottom few bolt holes. And so we're going to use those as anchors. And then we're going to apply our force up here, and then we're going to set the direction of that force. So we're going to move this arrow around to make sure it's facing the right direction. And then we're going to set this force to about 300 newtons, which is somewhere around 70 pounds force. So it's a decent amount for this little part. And we actually just did a simulation webinar. So if you want to see any more on this and how to calculate out these forces, I would encourage you to check that out. But for this case, we're sticking with our 300 newtons, and we went ahead and ran our validation for this. And the results are pretty impressive. We end up with less than 1/10 of a millimeter of deflection. And if we want to see how and kind of where that's being deflected, we can use this exaggerated animation, and it sort of shows us it's probably what we would expect. But more than anything here, we can take away that there's a factor of safety of 3 for this scenario that we simulated for. And so we can go forward with printing this part, and we can have full confidence that it's going to be able to handle what we're going to throw at it. And so we can install it and get our machine up and running again. But there is another piece that we may or may not use for a part like this, and it's on the back end of the print. So if we have a quality team that's really interested in knowing whether or not this part, the features are accurate enough and it's going to affect the parts that we have coming down the line, then we can set up the third piece, which is this scan. And scan takes advantage of the laser micrometer that's built into the print head of the Markforged printers. And that laser micrometer will actually scan these parts while it's printing, and then it compares it to the original file, and it will spit out a whole deviation plot report and inspection report for our QA department. And so we can set the density of those scans, so basically how frequently they happen and how thorough they are. And we can even set up surface groups, so if there's only one area that we're really worried about getting detailed scans, we can do that as well. But again, this part's pretty simple. I'll try to show a more interesting example here. And so this is one that we've printed out already and gone through the scans with. And so this is our plot report that we get pushed out. We can kind of narrow this down by which parts are the furthest out from what we expected. And we can even select individual features or faces, and we can get all kinds of information on how accurate those features and faces are. And then to get an overview of the whole thing, we can even print out this full inspection report for the quality team. And we don't even ever have to touch the part to get this thing. It's all up there, uploaded into Eiger. And at this point, we're all good with our scenario that we were working through. So we have our part, we have it in Eiger, and we have full confidence that it's going to be strong enough because we ran simulation on it. And then we have full confidence that it's going to be accurate enough because we're going to have this quality report to spit out once it's finished printing. But there is one other step here that I think is pretty cool. Because what if, this situation happens a decent amount of the time? What if these brackets are a somewhat common failure point or a wear item even? And what if we have multiple locations that use the same machine? Well, we don't need to have multiple engineers running through all of these things all at once. We can use, again, the digital inventory we talked about earlier, but we can take that a step further and we can have the line workers have access to our digital inventory. And we can sort of limit that access as we need to. And so the way that we're going to end up doing that is by using our role-based access control. And so we can set up our users, and those users belong to teams, and those teams have access to certain folders and certain device groups. So we can set up our line workers into these teams where they can have visibility to these folders, but they can only build parts in those folders. They can't change any settings or anything like that. And then they can only see certain machines, which are maybe the machines that we give them access to. And so this is the view of the line worker essentially. So they're in this folder. They can see the parts that they need to print. It's a read only. They can't add any parts in here. And again, they can't change any settings for any of these parts. So you can have people who have no familiarity with CAD or 3D printing or any of those things, and they can have access to this digital inventory. So whenever they need this part, they're good to go and they can print this thing out. And so coming back to one last thing I have not touched on just yet is this built-in dashboard here. And so this is our ROI calculator. And so Markforged has added this just to help you sort of justify these machines as you're using them. And so it compares, your alternative cost if you were to CNC machine or make these parts in a traditional method, and it gives you an idea of where your cost was with Markforged. So as you can see, we've saved a significant amount going through this. And then the other part of this dashboard is you can get your utilization. So we can see how much print time we've used up by user, how much material we've gone through by week, by month, however you want to split that up. And then this is that same page I talked about earlier where we can download our analytics report, and it'll spit out all of those custom fields where we had hex nuts and square nuts, magnets, whatever we were using in our parts. It's all tracked there, and we can spit it out from Excel that way. And with that, I think I'm just about out of things to talk about here with Eiger. So I know we've gone through quite a few things, so we'll do a quick little recap. And so we started by uploading our file to what we call a digital inventory. And so this is a place where we can organize everything and store our files for future use. Step number 2 was configuring our specific part and getting the print settings dialed into where we want, and then saving that all again to the digital inventory. Once we had our part set up, we ran through and validated the strength of our part using simulation, and we made sure that it was going to hold up through the situation that we were dealing with. Then we moved on to setting up an automated scan and quality report for this part that we can hand over to the quality team, and it gives us confidence that the geometry is all correct. And then the last step here was just enabling the line workers and the factory floor people to be able to print their own parts on demand as they need them by just giving them access to the stuff that they need to see and need to use. And with that, we're at the end. So I appreciate everyone sticking around with us today, and I hope you were able to get something useful out of this or see something interesting. And again, if there's anything specific that you want to go a little bit deeper with or ask some questions on, we're going to hang out for a little bit to do that. But we also have a lot of other resources, so let us know. But otherwise, everybody have a great rest of your day. Thanks.